the scanning of machines, trying to get more privilege to do more insidious things. And then this is a lot easier to do when you have a real-world software deployment, for reasons I'll discuss during the course of this presentation. And then crapware. This is a new term that's come up. Whenever you buy an OEM machine, a laptop, or you buy a computer or desktop, you have all those little tray icons, all those things are installed. All those things are just chock full of problems. So by having those there, you're inherent risks right when you install. And for those of us that are security experts and don't reinstall immediately or take them all out, everyone else is vulnerable to issues in these pieces of software. And then the funnel effect, which is what I call in the 90s, we moved attackers were attacking remote Unix software and go after its access control. And we had to shift towards, kind of happened slowly over 5-10 years, towards client software as people started closing down security holes. The attack surfaces shifted to areas where it was easier to find security holes, right? And the masses are always going to follow those trends. And I think we're going to start seeing more of a trend where we're going to attack local privilege escalation in operating systems. When Microsoft or Linux or OS X finally gets it right and gets that separation layer for usability on the web and the browser and then in the system, we're going to have to escalate privileges to, or not me, but attackers will have to escalate privileges to perform the steps they necessarily want to do. This is an overview of kind of what we'll talk about. This is a breakdown of the object manager, then the directory that's used, and this is all, but we'll discuss more later. Security controls in place, and then a technique to compromise systems that's somewhat unknown, and I'll go in depth in it and some new things that we've found. And then a tool that I've designed and written that'll be available on the iSec site that you can use to find these issues and remove them from a system. Or find the software that has these issues and then potentially remove the software, I guess. So the object manager. What is the object manager? This manages all the objects in NT. Files, sockets, all these things. Not necessarily sockets, but registry keys, LPC ports. All the objects in the kernel are managed by this component. It supports named and unnamed objects, so you can give an object a name for reasons why I won't talk about later. And of course, you have per process tables that the whole handle tables of currently open objects. And that's all tied together with the object manager. It's also, as I mentioned before, one of the most undocumented pieces of the Microsoft Windows operating system. There's a brief section in Windows internals that talks a little bit about it. That's about it. If you do a search, you won't find anything else. And it's a very large component for having no documentation. What is an object? Here's an example list of the ones people have seen all over the place. But virtually, I think there's 36 object types. They're there. So these are just a small snippet of the ones that you see. There's a lot of them that are in the kernel that you don't see very often. Here's some of the routines that the kernel uses to work with objects. To query, create object types. An object type would be like a file. And you can insert objects in the directory, which we'll talk about more. You can query for an object's name, given a handle or a pointer to it, to get the object name. So say I have a handle to a registry key. I can do a query for that and get the key. Some of those things. It's a little more trickier than that, but that's the general idea. Get object security. You can get a security descriptor, which has the DACL and a lot of the permissions associated with that object. And then you can open the object by name. You return a pointer or handle, the inverse of what we previously talked about. The problem is a few of these are exported. So if you want to write a driver or a component to work with these, you can't really touch them. You only have a couple you can access. I think it's one of the reasons that's not really documented. There's not a lot you can do to talk to it and work with it. Now the object directory. So most APIs offer a parameter like the create event, create file, or create like shared memory, all these things. You have a name parameter, or you give it a name. Those of you who develop software have seen this frequently. And this name is placed in the object directory. That's used for lookups and correlation. It's also used primarily for IPC mechanisms. You go and create a mutex or an event with a name, and process, B over here, can open that and signal it and set it and work with it, right? Without that name, you just have a handle. You can't really talk to it. Handles in the per process handle tables, like I mentioned, they have their own numbers. It's completely different than another process, for example. So that naming scheme, you wouldn't have much to work with. So here's the object directory. This is a snapshot taken from WinObj. This is a sysinternals tool that's been around for quite a while now. And you can see that the basic layout of the object directory, it's kind of like a file system in a sense. In fact, you have directories and you have names and you have a hierarchy there. And these have permissions and types associated, like a file system. But it lacks a lot of things like a file system, which we'll talk more about. But here we can see base name objects, which I'll talk more about as a key one. That's for global objects. And we have RPC control. All your RPC interfaces in Windows store a control endpoint there, which isn't really another thing that's not documented. A lot of these aren't documented. Windows are for Windows stations. You have your current sessions. So you have two people logged onto a machine, for example, terminal services. One will have an ID, maybe one, that'll be in there and have its own directory of objects. Another guy logs in, it'll be maybe two, and the directory of objects, and on and on and on. Known DLLs, these are preloaded DLLs. The system loads at runtime, and they'll copy those over as you need them on write. So they don't load them once. So a lot that goes on in the object manager for the performance of the system. Also, like whenever you go type C:// all that resolution for the drive name, the labeling is all done here too. And you see there's really strange paths in Windows where you have a C:// you have short UNC, long UNC. Some of that stuff is done in drivers in the system, but a lot of it is in the object manager. A lot of really awkward things you can do. There's actually symbolic links in here that loop around. They're circular if you're not careful. So you can create links that go back to themselves. It's really odd stuff. Choosing a name. So you prefix with global or local. As I mentioned before, there's global or local namespaces. And they have this little blurb in there that you can't insert a / character, right? Which whenever I see that kind of gives me an irk. Like I know that's being inserted into a control channel. Like you have format bugs exist. So when you combine data and control data together in one channel, and by parsing that, they can be parsed in a certain way and cause changes in the operation of that data. It's always a bad idea. And when you warn people, that's kind of an indication that they haven't figured out a way around it. So they specifically cannot use it, right? So it reminded me of this website I saw a few weeks ago. So that was kind of funny. It's actually on a banking website. Yeah, that gave me a lot of faith. I didn't have any faith in the banking community to begin with, but this just kind of compounded my fears. So local object. As I mentioned before, they reside in a session / the number, the session ID, and then / base name objects. So if I create an event, like let's see here, with the name iSec event, that'll be placed in /session /n or /1, for example, / base name object / iSec event. That's where it's going to be stored in the hierarchy. And global objects, it's just / base name objects. So you follow the pattern here, right? Each session has their own kind of containment, their own area for objects. Here's a global prefix. Now, if you notice, let me back up. This path is automatically placed. This object's automatically placed in my session. It's important to note that. I don't define that or specify it, or can I even control that? So the object manager directory. I talked about this briefly, but I'll iterate more. There's the global objects up there. And here's an example name of what would happen if I ran that function. Right, it'll create that object and base name objects and the sessions. There's one down there. So session isolation. In theory, these directories 1, 2, and 3 different session directories are isolated, meaning user A cannot cross boundaries into B or C. That'd be really bad if that were to happen for obvious reasons. This is one of the things we'll talk about, obviously. So I'm trying to quote everything I talk about because there's a stance from Microsoft that it's supposed to be this way. So I'm going to go with it's supposed to be this way, and maybe if I can show why it shouldn't be that way, then things will be fixed. So namespace instances, as I mentioned before, a little bit of a caveat there. Session 0 is for services. It'll never be assigned to a user. That's you think about UAC and these separations, a lot of them are done with a sessioning scheme. Do you see here? So directory security controls. So there's a tool called AccessTrack, which is a great tool, again, written by Mark Russinovich with system internals. You can run this on processes, files, registry, and search all of them for DACLs that are weak in Windows. This is great when you have a new application you want to deploy in your network, or you're reviewing an application, doing an audit. You can immediately you can do one before, then install it. You can diff that and get what's called a footprint, right, of what's been put in place. You get an idea of all the things that were introduced. For this purpose, I'm just showing the directories. You have a couple here that are read-write, RPC controls, and base name objects for global objects, right? So this is an important privilege in Microsoft Windows. That I didn't know about a lot of these until I dove into this the last 6 months. So bypass traverse checking. What this means is you have a hierarchy, right? You have directory, let's say A, B, and C. And directory A